What do you think makes you such a good nocturnal hunter? Well, visually it in the woods at night. The first thing you notice about it is its large outline. Those eyes are also constant vision from its perch on the tree. The secret of owl's ability to hunt lies in its good night vision, which in turn lies in the size and construction of its eyes. In fact, its superb nocturnal vision involved two quite separate capabilities: the ability to discriminate fine details of the object within the visual field, and the ability to perceive a small quantity of light. Therefore, the owl's eye are not simply giant versions of those of its living cousin, as you might suppose. During the daytime, there is plenty of light, as those eyes of Diana are like great squirrel mama have a relatively small window, the cornea. Now, the amount of detail capable of resolution by the eye will obviously increase with the size of the image, and diurnal species of animals, they tend to differ with long focal lengths, which means compared to large for the retina way back from the lens. However, the larger image gets, dimmer it becomes too. Register in the retina. In contrast, one of the first essential for an eye operated by night is that it must be correct and concentrate as much light as possible. The eyes of owls are large, but size alone is not enough. Obviously, the design must differ from those of diurnal animals. One of the most striking features of an owl's eye is the relative size of the window. In photographers' jargon, nocturnal eyes are fast. That is to say, eyes for size, they are capable of letting in far more light than diurnal ones. In practical terms, a fast lens is wider than a slow one. When there is not enough light for the slow rays to offer, the fast one correct enough to throw a bright image onto the film. The same analogy can be drawn between the eyes of owls and beavers. Now let's take a look at the figure 1 and compare the vertical section of the eyes of diurnal species of birds and of the owls. Since an owl's eye has a large cornea, the system would tend to throw a large image a long way back, just like in the daytime time with a comparable loss of brightness. At the same time, however, rounder and more powerful lenses bring a much brighter image back closer to the lens. In the world, their eyes give out high resolution with which they can see details in the dark. The optics of their system, together with the fact that they have a higher sensitive retina, makes owls very well equipped to probe the darkest nook by night. Well, the risk of stumbling and groping the dark, while the others are capable of an external feat of weaving in out of the trees night with no trouble at all. There is another conspicuous difference between our eyes and ours. Unlike the eyes of mammals, the eyes of birds are reinforced by bony fur structure, the bind of cornea and tuft over layer on their huge skull. That's why owls cannot open their eyes sockets and we can. They cannot roll or move their eyes. That is, they can only look straight ahead. But a head can turn a considerable angle to accomplish the same purpose. Because the owl's eyes are separated by a significant distance, they also have a good stereo vision and depth perception. One last thing is it's a popular misconception that owls are blind by day. After all, some species hunt by day, and the creature is eagle owl and more are killed by owls by day. Nevertheless, the relatively enormous tubular eyes of birds highly pieces of equipment tuned for night life. So they are gray of daylight, and now in this function, their muscular irises play an important role. 啊，因为